Okay, welcome to Physics 20. Yeah, so it's a science course, deeply rooted in math. So you have to be strong in your math to have success in this course. But with that, you have to be able to think. Like in physics, you will have no success if you are unable and unwilling to think about what's happening. So it takes logic, and it takes imagination, and you have to visualize, and you have to work hard, okay? Physics is probably one of the toughest courses in that sense. Like, you really have to put your best effort forward. Some people are gifted in math, like they can just look at a concept the teacher puts forward, and they can really just, they might even be able to breeze through it. I haven't found too many people that are able to do that with physics. There are some, of course, but not too many. So let's go over some of these mathematical relations that you need to be aware of. You have linear, square, inverse, and inverse square. Those are just a few, but those are the main ones that are emphasized in Physics 20. So hands up, you guys know linear? Just somebody, what's linear? Ah, very nice. So she said plus b. You don't really need the plus b, but it could be there. It's just y equals mx. And what does m stand for? What is m? Okay, in math they call it slope for sure, so it's just a proportion. It's a proportionality constant. So for example, in physics there's a famous expression called Hooke's law, and it's F equals kx, where the force is just equal to some constant k multiplied by the distance that you stretch a spring. So mathematically, it's quite simple to explain and think about. And through the lab, you'll see that it's just a linear relationship. So the next one is square. What's a square relationship? Y equals square. What would the independent variable be? Obviously, x squared, yeah. Okay, and that mathematical relationship is studied in Math 20, not Math 10. So hands up, you have not taken Math 20. I have not taken Math 20. Okay. So Math 20 is not a prerequisite for this course, but it's recommended that you have it. If you're taking it at the same time, that's better. If you're not taking it at all, there will be some situations where I'm talking about something and you might not even know what I'm referring to mathematically. There are relationships, you probably remember, does anybody know the formula for kinetic energy? Kinetic energy from Science 10. 1/2, anybody remember? 1/2 m v squared. So the 1/2 m, that's a constant, but the velocity squared, that's the variable of interest. Come on in. You need your bag? Where's your bag? Did you switch classes? You're in this class? Okay. So the inverse and the inverse square relationship, that's actually studied in Math 30, and you really only need to know about it sort of at like a very surface level. You just have to know about it. You won't have to do too much math on it. So that's inverse would be y equals 1 over x, and inverse square would be 1 over x squared. Come on in, grab a blue book. Yeah, sit anywhere you feel comfortable. So just as a nice little math warm-up, you notice all these equations. What is the y? What do we call the y in science? In math, they'd call it dependent variable. What would they call it in science? Manipulated or responding? Responding. The responding variable always goes on which axis? Obviously the y-axis. And the x, in math, they call this the independent variable with the input. In science, they'd call it the variable that you're manipulating. So like if you take a look at this kinetic energy equation, which variable corresponds to y? EK or V? EK. Because I've written EK alone on the left, and I got Y alone on the left for those other ones. It's just like a convention. If I put Y alone on the left and all the other stuff on the right, then I have an easier time understanding what's the manipulated and what's the responding. So the V, what V stands for? Velocity, okay? So, or speed. So depending on how fast you're going, you have different amounts of kinetic energy. So if you're going slow, you have a little bit, and if you're going fast, you have more, if you're the same mass. Alright, so like I said, come on in, grab a seat. There's a blue book there for you. Physics 20, grab a blue book. And any notes you might have missed, I'll put up on YouTube. It's just a page. Okay, so this linear relation, it's studied massively in Math 10, and you should know it pretty much off by heart. Y equals mx. Sometimes there's a plus b in there. So in math, you know it's mx plus b. What does the b stand for? On the graph. Good, the y-intercept. It's which value is the slope? The proportionality constant. Good. So the y-intercept is important because it's like a starting point. So make sure you know that right now. The y-intercept is called the initial value. Because what would happen if x was 0? What happens when x is 0? Y equals, if x is 0, y equals, just yell it out, b. Because m times 0 is 0 plus b, y equals b. So if x is 0, that's your starting point. That's like an initial value. Okay, and then the slope is this proportionality constant. It tells you how much your independent variable is increasing or decreasing by. Is it going up by 2? Is it doubling? Is it going down by 2? Is it halving? Is it tripling? Stuff like this. Was there more on that slide that I missed? Oh, just the graph. Okay, so notice on this graph, what's the y-intercept? Because b is 0. You can see it's like right over here, mx plus 0. So the y-intercept is 0. And how would you measure the slope? Do you guys remember? What's the phrase for slope? Something over something. Rise over run. So you would need a run and you would need a rise. Any 2 points. Doesn't matter which 2 points? Does it matter? Any 2 points. And you need the change in the horizontal. They call that the run. In physics, we would call that delta x. Why delta x? What's delta? Change. What's x? Obviously the horizontal component. What's the rise? If it's delta x is the run, what's the rise? Delta y. Good. Delta y. So for the slope, what's the slope? This value here, k. All you'd have to do is go k equals rise over run. Or in physics, you'd be like delta y over delta x. Done deal. you have to know how to do slope. Slope is probably one of the most fundamental skills in science, especially at a high school level. Because if you take a calculus course, if you think you're going into maybe some university or some college level science, you have to know slope. If you're taking calculus, it's like slope, amped up on the difficulty. It is slope, but it's a little bit more difficult. So here's the square relation in math. There'd be another side to this. Like, have you guys ever seen the parabola? This is called a parabola, that shape. Like in physics though, typically you wouldn't be too worried about the left-hand side of that graph. Why? Probably because x is the time, and you probably wouldn't need to see it, but nevertheless, there's the square relation, y equals x squared. It's a parabola, and it's studied in Math 20. The inverse relations, this is a graph at this level in your life you don't have to worry about too much. Like in Math 30, you'll treat this one, and Math 30-1 anyway. Okay, and there are some relationships that are inverse. For example, period and frequency are inverse. So frequency is 1 over period. So what does it mean to be inverse? So think about this. As x gets larger, as x increases, what do you notice about the y? The y is decreasing. So that's inverse. Now go the opposite direction. What happens if x is decreasing? If x is decreasing, what do you notice about y? It's increasing. That's inverse. Inverse proportionality. And then the inverse square relation is special to physics because there are some pretty important laws that have this, namely gravity and the electrostatic repulsion. That's in physics 30. In physics 20, you'll see this one here. It'll be force due to gravity, some constant, g, a couple masses, so mass 1 and mass 2, all divided by the distance between them squared. So you can see that the force is inversely proportional to the radius squared. So it depends on how close you are. Okay, so if you're really close to Earth, you're attracted more to it. If you're far from Earth, you're attracted less to it. So that's an example of that. So today, I guess we're going to focus on some algebra, get you guys warmed up for the course. So this one here, this is Science 10, V equals D over T. Before we get started, what is that little bar above it? Good. The little bar means vector. If it didn't have the bar, it would be a scalar. So in terms of the variable d that you see in this equation, what's the word for the vector? Good, displacement. What's the word for the scalar? Good, distance. What about the vector v? Of course, go right in there. So for v, did it work? There's another one here. Velocity and speed. You can just go to your desk. It's all good, man. So for v, velocity and speed. And what about t? And what do you notice about time? Does it have the bar? So time, you don't have this distinction between velocity or scalar and vector. Time is just time, okay? Time is on its own. You have three-dimensional space that everybody lives in. So we live in this three-dimensional space. The reason we know it's three-dimensional space is not because someone just decided that. It's through experimentation. So for example, if we had something that produced a vapor, like maybe we were boiling water or something, and we had this gas that was spreading out in the room, it spreads out three-dimensionally. And that's how we know we live in a three-dimensional world. Sometimes people will say, well, we live in 4 dimensions of space and time. So you have 3 dimensions of space and 1 dimension of time. Okay, so for all intents and purposes in this class, we live in 3-dimensional space and we use this other dimension of time to measure things. Okay, and we all as human beings understand time because we all feel it in some sense. And for the most part, you guys should know this formula here from Science 10. Do you agree? Yeah, so what is it saying? You cover a certain amount of distance in a certain amount of time. What happens if the distance variable is very, very large and the time variable is very, very small? Are you going fast or slow? So the larger this d is and the smaller the t is, you're going quite fast. What's the fastest thing in the universe? Speed of light. Is there anything faster than that? No. So there's a universal speed limit. And Einstein said that right at the beginning of the 1900s, and Einstein's never wrong. So you can just take it for granted. Now, what happens if t is very, very large and d is very, very small? You're going slow. So in terms of slope, what would this look like? What goes on the y-axis? D or t? D. And what goes on the x-axis? T. So what did I say? What if time is very, 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 very long and you only cover a short amount of distance? How steep is the slope? Not very steep, is it? So one of the first things you'll see is that you can find the speed by doing a graph of d versus t and then looking at the slope. Okay, so that's one of the first exercises we're going to do as a class. Now, contrary to that, what if you had a very, very short time and quite a huge distance? What do you notice about that slope? Much more steep in terms of slope. So this would be delta d, and this would be delta t. And what happens when you do delta d divided by delta t? What do you get? Speed. Right? Okay, so let's do some algebra. Isolate for d. What's the formula? Isolate for d. D equals d equals vt. Right? So what happened there? Bottom right goes to top left. Downstairs on the right, upstairs on the left. And then all I did was rearrange it so that d is isolated on the left. So vt equals d. And then we put d alone on the left. Now what do you notice about this formula? Is it linear? Is it square? Yeah, you can put the thing on top if you want, yeah. It's linear, right? What's the proportionality constant? V. And what is this proportionality constant? The slope. All right. Let's keep going. So this formula is for acceleration. We'll talk about it when we get to this section in kinematics. For now, we're just doing algebra and just basically talking and warming up. So this VF minus VI, what do you think that stands for? Final and initial, in terms of velocity, right? So what is VF minus VI? And this can be for any variable, okay? I'll just use X. XF minus XI. Is there a symbol that we could use to replace XF minus XI, make it nicer? Delta X, lovely. So in physics, you need to remember final minus initial as delta. Final minus initial is delta. So this formula really is just the acceleration is delta v over t. Delta v over t. So what does that say? The change in speed or velocity divided by time. So what happens if you go from 0 to 100 real quick? You recognize that? Obviously. You go from no speed at all to 100 kilometers an hour quite quickly. Are you accelerating fast or accelerating slow? So that's acceleration. How much, or it's a measurement or a representation of how quickly your speed is changing. What was the last one about? How quickly the distance is changing. That's velocity or speed. But how quickly the speed is changing, that's acceleration. Okay, so let's solve for VF. Go ahead and solve for VF. You can try it, and then I'll put it up. Try to solve for, like, isolate for VF. If you're stuck, how many of you guys are moving T first? Are you guys moving T first, or are you going to deal with VI first? Which one do you deal with first? Which one do you got to move first? You got to move T first. So if I said isolate for VI, or pardon me, isolate for VF, the problem is they're both being divided by T, right? So if I want to isolate for VF, I got to deal with T first. So where can I put that T? Good, because if it's downstairs on the right, it needs to go upstairs on the left. So then you have AT is equal to VF minus VI. Now I can definitely isolate for VF. What do I need to do to that VI? No. Move VI to the other side. Right now, VI is negative or positive? Right now. It's negative. So it needs to go to the other side as a positive. So on the other side, VI is positive. So you have AT plus VI is equal to VF. Now I'll just rearrange it so it's on the left. VF equals AT plus VI. What does that look like? If it was linear, what would this equation in math look like? This would be the Y. This would be the M. This would be the X. And this would be the B. And that would only be for a constant acceleration. You would have a linear VT graph. That would be V versus T, linear acceleration. Okay, here's another one that you'll have to be pretty fluent in. How about we solve for VI? Solve for VI. See if you can do this one. Solve for VI. Okay, so what'd you guys do first? Move the 2AD. Why do you got to move this 2AD? because VI needs to be isolated by itself. So this whole 2AD has to get out of there. So is 2AD positive or negative on the right? So on the left, 2AD has to be good. So you have VF square minus 2AD, and that equals VI square. Now if I want to isolate for VI, how do I deal with the power 2 here? So you've been trained to use a square root for that, probably from Pythagorean theorem in junior high in math 10. So yeah, you would want to go square root. And there's little invisible brackets in there saying that you need to calculate that VF squared take away 2AD and then do the square root of the result. And also like later when we're doing like actual questions, like I don't always do it algebraically. I usually just pump numbers in and then solve with numbers. So, but it's good also to practice this. So this one we'll leave it as a challenge. How about you guys solve for, what should we do here? Solve for A? Let's do that. Solve for A. Okay, we'll leave that one as a challenge. So solving for A. What I tell students often is, find where your variable is. So where is the variable? A is inside this term here. So if I want to isolate for A, I got to isolate that term. So write this in. Isolate the term. The thing that's highlighted. So where does that VIT need to go? On the other side. How do you get it there? Not divide. Often your first step is an addition or a subtraction. Isolation often, especially, what's the big tip off here? And I'll put a big thing of red on it. That plus. If there's more than one term, to isolate, you often have to move it to the other side with addition or subtraction. So because VIT is positive, it goes to the other side as a negative. VIT goes to the other side. So you would subtract VIT. Now, I want to isolate A. You guys agree? So what needs to get moved? The 1/2 and the t square. Now it's okay to divide. Why? Because they're just multiplying in there. There's no more addition or subtractions in there. So you can divide by 1/2 t square. Or you could times everything by 2 and divide by t square. A lot of students will just do this, so divide by 1/2 t square. And of course there'd be some invisible brackets here, like you need to take d minus VIT, get that result, and then divide by 1/2 t square. And that would cancel those, and you would have isolated A. So again, like that's definitely a challenge, especially first day back. But it's a nice little, it's good for us to see the difficulty. You have a question? Times it by 2, you can definitely do that. Yeah, I in fact do that myself. So like if you had like EK is 1/2 mv squared and you wanted to solve for V, I would go 2EK divided by m and then square root that. Yeah, I prefer that actually. I don't like dividing by half. I much prefer times by 2. Oh, I already did that. So how about you guys solve for m? And this one you can solve for h. Okay, so solving for m, what'd you do with that 1/2? Times it by 2, so on the left you'd have 2EK. And then how do you get rid of that v squared? Divide it out. And then you'd isolate for m. Solving for h, what would you have to divide out? mg, good. So you'd have EP over mg. Now I'll just stop you there, because what happens is students, and this one really frustrates students and teachers alike. It's like, here we have EP divided by mg, isolated, solve for h, you feel great, you've done good math, everything looks good, you put it in your calculator and you screw up. So what would be the problem in the calculator here? Brackets. So for this one in the calculator, you would have like EP, whatever that value is, and then when you hit divide, you make sure that it's going to be dividing by the product of mg. Because if you just go divide m and then type in g right next to it, the calculator will most likely times that g and you'll screw up. So I'll let you try the next few pages on your own, and then I'll walk around and just get to know you guys. And for this one, I'll have you solve for r. Okay, the next one, how about we solve for r again? That's 4 pi squared rm. That's for centripetal force. And then for the next one, I'll have you solve for F. And the last one, I'll have you solve for L. And that'll be the rest of class. And I'll walk around getting to know you guys. And that's it for the first class.